Hello all, we are group 4. I am Joanna Macias and I am here with Julia Morden and Jason Chen. Today we will be talking about data mining for Amazon Books. We will be going over the background information of the data, how we can use the data to find the most profitable authors and publishers of books that are sold on Amazon, why we do data cleansing, how we determine significant statistics through linear regression and clustering, and at the end we will give our final conclusion. Amazon collects a lot of information about the books it sells, but our specific data set we will be working with will include the title, author of the publisher, listing price, Amazon price, whether the book is hardcover or paperback, the number of pages each book has, the publishing year, the ISBN 10, the height, width, thickness, and weight of the book. Through the use of Alteryx, we will be able to determine the following information of the books sold on Amazon. First, we will be able to determine the oldest and newest book, oldest being 1936 and newest being 2011. The cheapest books that are sold on Amazon, which is about 77 cents, and the most expensive Amazon price, which is $139 with 95 cents. The heaviest book, the lightest book, the most and least number of pages of the books that are being also sold on Amazon. With this data, we can find the most profitable authors, which is important for Amazon when it is comparing its prices with retail prices. Amazon can also make the most of this data by determining which books sell for less on their platform and make some of its money back by charging the difference to the publisher. Thus, we can use the Alteryx workflow to show the authors and publishers that have the greatest difference in price between the listing and Amazon price. Below is the pathway we have designed in order to extract, calculate, clean, and sort the data into data tables that can later be analyzed. Once we run the Alteryx workflow, we get the top 5 publishers and authors displayed in the table below. The top 5 publishers are Wadsworth Publishing, Stage Publications, Harper, Knopf, and Atria, while the top 5 authors are Mary Wisner Hanks, David Matsumoto, John Hellman, Mark Halperin, Joseph Williams, and Mick Cooper. When looking at the price difference for the top 5 publishers and the top 5 authors, we see that the price tends to be higher for the average listing than the average Amazon price. When looking closer at the Amazon dataset, we see that there are several values that are missing. So in order to ensure accuracy, rows with no values were removed with the Alteryx by selecting the customer filter that can find the missing values of authors, titles, Amazon pricing, etc. Now that the data is cleansed and the Alteryx workflow is designed, we can determine possible conclusions from the dataset. For instance, the Amazon's book dataset provides opportunities to determine how a price can be set. Other significant numerical data that can be analyzed are the number of pages a book has, a publishing year, and the weight of the book. This additional data can be used by Amazon to know what books should be kept in their warehouses and how much space each one is going to take. We can also do some statistical analysis on the data, such as running a linear regression. A linear regression will help us determine which data points are the most significant for making prediction. The estimate will determine the relationship between the different variables. We can also calculate the p-value that determines the significance between the relationship. Through linear regression, we can see if there is a relationship between the number of pages and the Amazon price of the book. On the right is a snapshot of the results we obtained from running a linear regression on these two variables and we see that the estimate is 0.005609, which means that for every increase in one page of the book, the Amazon price increases by 0.005609 cents. This number is too small to be significant. Moreover, the p-value is 0.1761. This value is higher than 0.05, which signifies that this relationship is insignificant, and the number of pages should not be used as a predictor. Another relationship we can look at is the relationship between the publishing year and the Amazon price. On the right is a snapshot of the results we got when running a linear regression. The estimate for this regression is 0.08052, meaning that for every increase in year, the Amazon price increases by approximately 9 cents, which means that this value could be significant. However, when looking at the p-value of 0.18996, this shows that the relationship is not significant. Thus, the publisher year could be a useful indicator. However, we would need to be cautious since this does not apply to the whole model. A third relationship we can look at is the relationship between the Amazon price and the weight of the book. In this case, the estimate is 0.5018, which means that for every increase in weight, the Amazon price increases by approximately 50 cents. This value could be significant. Moreover, when we look at the p-value of 2.72 times 10 to the negative 7th power, we see that this relationship is significant, meaning that the weight is the best indicator of Amazon price, and the heavier the book is, the more it costs. Another analysis we can do is a cluster analysis. We can use the k-means cluster analysis to determine if the relationship between the two variables are significant. The difference between the centroids of the clusters determines the strength of the relationship between these variables. Using this cluster analysis method, we can again analyze the relationship between the publication year and the listing price. When looking at the graph, we see that the distance between the two publication year clusters and the pricing of the book is small. Therefore, this relationship cannot be used, as we previously saw in the linear regression model. When looking at the number of pages and the Amazon price, again we see that the distance between the two page number clusters is small. Therefore, this relationship should not be used either. However, when looking at the distance between the two weight clusters, we see a larger distance. Therefore, this relationship should be used, and there is a significant price difference between the heavier books and the lighter books. In conclusion, by utilizing linear regressions and k-mean clusterings, we reject the conclusions that the publishing year and number of pages can be used to determine the Amazon price. However, we accept the conclusion that the weight can be used to determine the Amazon price. Thus, through data mining analysis, Amazon can determine that they should stock heavier books as opposed to lighter books, as these books can sell for greater price, netting better gains for Amazon and their publishers. Thank you.